All right, welcome to sections 2.3 and 2.4. So section 2.3, we're going to talk about systems of linear equations in two variables. So systems of linear equations. So a system of linear equations is a collection of linear equations containing the same set of variables. So remember linear, remember that means it's a straight line. It's the equation for a straight line. A solution to a system of equations in two variables is an ordered pair that satisfies both equations of the system. And that's important here, both equations. So once you find x and y or whatever your two variables are, then we're going to plug back into both equations and make sure both remain true. Okay, we'll do that in a little bit here. So break even. This is something you might see in one of the homework problems. A company is said to break even when the revenue equals the cost, right? So R of X is your revenue equation. C of X is your cost equation. Revenue is how much money a business takes in. Cost is how much goes out. Profit, right? P of X is revenue minus cost. So how much money they take in minus how much money they spend. So hopefully in any business, you want to make sure you take in more than you spend, so you have a positive profit. All right. So here's an example for break even. Suppose a company has its total revenue for a product given by R equals 5585X, right? And its total cost given by the cost equation 61,740 plus 440X, where X is the number of thousands of tons of the product that are produced and sold every year. The company is said to break even, again, when the revenue equals the cost, when R equals C. Find the number of thousands of tons of product that gives the break even, and how much revenue and cost are at the level of production. So what you could do, and I'm not going to go over it too much in this class, but what you could do is graph the two linear equations. And we know they're linear, right, because they're of the form y equals mx plus b. Remember, m is your slope and b is your y-intercept. Right? So whenever you have an equation in that form, you know you have a straight line. So if we were to graph these two straight lines, and you can see them right there, there's the two separate equations graphed, then the break-even point, even means equal, right? So the break-even point is where the two graphs meet. Okay, that's where the two graphs are equal. So you could see, it's not going to be perfect, but it's somewhere around 12,000 there. And you can tell this is just a little bit over 60,000 there, so almost the 70,000. So if you were to read this graph really well, you can say the company will break even on this product if 12,000 tons of the product are sold. Right, there's the X value, 12,000. When both the cost and revenue equal $67,020. Okay, so again, that's what you would do graphically. We're going to concentrate mostly on the algebraic way to solve these problems. Here's just another example of what we just talked about. So solve the system of equation. So what you would do if you're going to put these both into your calculators, you would solve each one individually for y. In other words, get y by itself algebraically, and you'll see there's the two solved for y. And you would plug those into your calculator, graph them, and again, where they meet up, that is your solution, right? Where the two graphs overlap, that is a solution to the system of equations. So whatever that ordered pair is, excuse me, you can see both those x and y values. If you plug them in to both equations, you'll get a true statement. All right, we have solution by substitution. So when we have these systems of equations, these two equations with the same variables, we want to solve them. We want to find where they overlap, if they do. And we'll talk about what happens if they don't in a little bit. So here, let's see, solve one of the equations for one variable in terms of the other. So substitution, substitute, to replace, right? Substitute the expression from step 1 into the other equation and give an equation in one variable. So that's what this is going to do. It's going to help us reduce down to one variable so we can solve for that variable. Substitute this solution into the equation from step 1 or into one of the original and solve this equation for the second variable. And then this is important here, number 5. Check the solution in both original equations. That's the important part, the original equations, because if you don't use one of the original equations, if you use one of your newer equations that you've modified or manipulated, you could get what seems like the right answer, but it could still be wrong because maybe you made a mistake earlier. Okay? All right, so here's a few terms. You don't have to memorize these terms. Just use this list to understand them when you're doing the homework. So demand, the quantity of a product that is demanded by customers. Pretty obvious, right? Supply, quantity that is supplied from the manufacturer. Surplus, if the price results in more units being supplied than demanded. So if they overproduce, then you have a surplus. If you underproduce, in other words, if your customers want more and you ran out, that's a shortfall. And market equilibrium, equal, right? Supply equals demand. Okay. So here we go. Here's an example, market equilibrium. Suppose the daily demand for a product, so here's the demand equation, that one right there, and we're just going to make a little note here. We're going to say this is the demand equation, is that where Q is the number of units demanded, P is the price per unit in dollars, and daily supply is given by the second equation down here. So that's that equation where Q is the number of units supplied and P is the price in dollars. Market equilibrium occurs when the supply quantity equals demand quantity and when the prices are equal. That is when Q and P both satisfy the system. Okay, so number 1 here, they're saying if the price is $140, how many units are supplied and how many are demanded? So in other words, we're going to take 140 and substitute it into both of these P's, right? Separately. So let's see. We have our first equation so it asks for supplied first. So we'll do the supply equation, the bottom one here. So we're replacing the price with 140 as it says, equals 60 plus 5Q. So we go through our algebraic steps here. Of course, we're going to subtract 60 from both sides. That's the rule, right? Whenever we're doing algebra, whatever we do to one side of the equal sign, we do to the other equal sign. And we always want to eliminate the numbers first, then divide out to get the variable by itself. So we're going to subtract 60 from both sides. So that'll give us an 80 equals 5Q. Then divide both sides by 5. So we get Q equals 16 units supplied. All right, that's what they were asking us first. So 16 units supplied when the price is 40. Now they want to know what's the demand when the price is 140. So we do the same thing, but we use the demand equation on top here. So 140 equals 200 minus 2Q. Same process again. Let's get rid of the numbers first. Then we'll divide out to get the variable by itself. So we're going to subtract 200. So be careful. We're subtracting 200 from both sides. So you have 140 minus 200, which of course is a negative 60. Equals negative 2Q. All right. Then we divide both sides by negative 2. And Q equals 30. All right, so that's 30 units demanded. And there we go. So we answered both questions there. Okay. So positive 30 units demanded So that means they have, let's see, so we have a shortfall, right? Because the customers are demanding 30 units, but the company's only producing 16, right? So when the demand is greater than the supply, we have a shortfall, okay? All right, and then part C asks what price gives market equilibrium? Solved by substitution. Okay, well that's easy enough. We have our two equations up on top here. Well, they're both equal to P, right? This is equal to P, this is equal to P, and we know P is equal to itself. So we substitute. We'll get 200 minus 2Q equals 60 plus 5Q. Okay, and we work on algebra magic. So, and it doesn't matter where you start. You could either subtract 200 from both sides or subtract 60 from both sides. It all works out the same. I personally like to go with the lower numbers. I like to keep numbers positive if possible. So if we subtract 60 from both sides, we'll get 140 here minus 2Q. 60 minus 60 is 0. We're subtracting from both sides, plus 5Q. Now we want to get all the variables, all the letters, to the other side of the equation. So we'll add 2Q to both sides. So 140 equals, so negative 2Q plus 2Q is 0. 5Q plus 2Q is 7Q. And then we can divide both sides by 7. So Q equals 20. And in this case, this is a price. So there we go. $20. Or wait, let's see. Q. Oh, Q is the number of units. My mistake. So we didn't actually answer the question yet. 20 units. Oops. 20 units will give us market equilibrium, but it says what? Price. So what we're going to do is we're going to take this Q equals 20, and we pick either one of the two original equations. It does not matter. Usually pick one with lower numbers. It just makes the math easier. But we're going to take one of the original ones. P equals, I'm going to use the second one up there, 60 plus 5 plus 5Q. And we know Q is 20, so the price is 60 plus 5 times 20. So equals 160, right? So it'd be 100 plus 60. So the price is $160 when you have market equilibrium. Okay, this is more typical of a problem you'll see on tests or quiz or homework. They'll give you a system of equations here, and we're gonna substitute. All right, so it says right here. So you got to know both methods. There's a substitution and elimination. We'll talk about elimination in a minute. But you need to know both methods, right? Because if the test asks you to do it one way or the other, you got to know both ways. Okay, so substitution just means get one variable by itself and then plug in. Okay, so let's do that. You always want to try to choose wisely. Choose an equation that's going to be easy to get one variable by itself. And if we kind of look and through experience, this second equation, the bottom equation here, is going to be easier to get one variable by itself. All right, so we're going to take that second equation, 6x plus 2y equals 14, and I want to solve for y. You can solve for x, it doesn't matter. Pick one. I'm going to solve for y, so that means I'm going to subtract 6x from both sides, and then divide everything by 2, so that's important. Everything gets divided by 2. 2 over 2 is y. Now remember, when we divide like we are here, we have to realize we have two separate fractions here. So be careful with that. These are two separate fractions. We have 14 over 2, and we have negative 6x over 2. Okay? We could simplify these. make it a lot easier. So y equals, so 14 over 2 is 7. 6 over 2 is 3. Okay? So now we got the second equation here, we got y by itself. So when we do the substitution method and this is important, plug into the other equation, not the one you just used. Plug into the other equation. So that's what we're going to do here. We're going to take 3x plus 5, y equals -1. We know y is really 7 minus 3x. Now we're going to plug in. So 3x plus 5. Now notice how I use parentheses here. All right, parentheses are very important because we have to distribute that 5 into the 7 and the -3x. That's important. All right, so again, we're going to distribute, right? We're going to multiply that 5 into the parentheses. So we get 3x plus 5 times 7 is 35. And 5 times -3x is minus 15x, and that's -1. All right, and then we're going to combine like terms. Remember, like terms have the same variable, same exact variable. So 3x minus 15x will give us -12x. And I'm going to subtract this 35 from both sides. Okay, I'm going to subtract the 35 from both sides. So that one, the one on the left goes away. And -35 minus 1 is -36. Okay, then we divide by -12 on both sides. Negative over negative is positive. 12 over 12 is 1. Again, negative over negative is positive. And 36 over 12 is 3. Okay? Now, that's not the final answer. That's just part of the answer. Because when they say solve the system, we need to find both x and y, or whatever the two variables are. We need to find both variables. But the nice thing is we now have x, and we actually already had y by itself right there. Okay, so we're going to take that equation. So we've got y equals 7 minus 3x. And we're going to plug in that 3 that we just found. So y equals 7 minus 3 times 3. So y is 7 minus 9, which is -2. Okay. All right, so now we have x and y. Now, to check it, I'm not going to actually show it right now, but to check it, what you're going to do is you're going to take this x equals -3 and y equals -2, and you're going to plug in separately to each of these two equations. Right? We can kind of do this quick, like do a quick check. Let me clean this up here. Okay, oops, I want to keep those answers circled. Let's see, if x equals 3, then that's a 9. Y is -2, so that's -10. So 9 minus 10 is -1. See, it works. Check the other one. X is 3, so that's 18. Y is -2, so that's -4. 18 minus 4 is 14. Okay, so the check works. We got the right answer. That's a guarantee that you have the right answer as long as you plug in correctly. Okay. All right, elimination is the other way to solve these types of problems, these systems of equations. So we rewrite one or both of the equations in an equivalent form that allows us to eliminate one of the variables by adding or subtracting the equations. All right, so here's some basic steps. If necessary, multiply one or both equations by a non-zero number. Obviously, if we multiply by 0, everything goes away, and we don't want that. That will make the coefficients, remember the coefficients are the numbers in front of the variables. So let's see. Coefficients, oh yeah. So we're going to make these coefficients equal, except for a sign, but I'm going to show you how to do this, no worries. Add or subtract the equations to eliminate one of the variables, right? Hence the term elimination. Solve for the variable in the resulting equation. Substitute the solution from step 3 into one of the original equations and solve for the second variable. So just like we did in the last process. Check the solutions in the remaining original equation or check graphically. Okay, so when you do elimination, right? So this is a system of equations, 2 equations with the same variables in it. When we're solving, we're trying to find the relationship between these 2 equations, right? That XY solution, right? So think of a relationship. In a relationship, what do we always want to do, right? I'm joking, of course, but what we're going to do in a relationship is manipulate one or both of the variables to get what we want out of it, right? Okay, little math joke there. So usually I'll ask my students, hey, so which variable do you want to eliminate? Well, remember, this is a relationship. Don't we always want to eliminate the x from the relationship? Haha, I know, big joke. But in reality, you can choose either the x's or the y's to eliminate, okay? Pick the one that's going to be easier. So we'll look at these 2 equations right now. Eliminate as in we're going to add the variables straight down to get a 0, right? We got to manipulate these first. We notice right here, look, this is a 3 and a 6. What if I take this top equation and multiply by -2, the whole thing, everything, this one, this one, this one, everything by -2. What if I do that? Let's see what happens. Okay, so multiply everything by -2, we get negative 6x minus 10y equals +2, right? Okay, so then we're going to move this bottom equation over. We're just simply copying it down. Okay, and what we're going to do is we're going to add straight down. So notice what happened. Look, we have a -6x plus 6x, which is 0, right? Those go away. That's what we want. We just eliminated a variable. Then we have -10y plus 2y, which is -8y. And we have 2 plus 14, right? Which is 16. Now we want to solve for y. That's nice and easy. Divide by a -8. Right? Negative over negative is positive. 8 over 8 is 1. So we got y by itself. 16 over -8 is -2. Okay. All right, so we got y equals -2. Now what we're going to do is we're going to pick one of the 2 original equations here, plug in this -2 for y, and get x. Doesn't matter which one you choose. I'm just going to choose this second equation down here. So 6x plus 2 times, we know y is actually -2. Watch your parentheses here. Equals 14. So we've got 6x minus 4 equals 14. Add 4 to both sides. All right, so we get 6x equals 18. And divide by 6 on both sides, x equals 3. Now notice we use the same 2 equations here as we did up above for the substitution method. So we know x should be 3 and y should be -2, and that's what we got here. So we got the same answer, just simply using a different method this time, okay? In your homework, you're allowed to use whichever method you want, either elimination or substitution, unless the problem specifically says use elimination or use substitution. Okay? All right, now everyone's favorite here, word problems, right? We love word problems. No? Yeah. Well, I do, but I'm a math teacher, so something else already wrong with me, right? Solution of real problems sometimes requires us to create 2 or more equations whose simultaneous solution is the solution to the problem. That's just fancy math talk for create 2 equations, use the 2 methods we just talked about, or either one of the 2 methods we just talked about, and solve for both variables. Okay, so here we go. So here is a typical test or quiz type question. So let's see, example, investments. An investor has $200,000 to invest. Part at 8%, and the remainder at 3%. If her investment goal is to have an annual income of $13,600, how much should she put in each investment? So we're going to use the equation, this one right here, amount, so A, so just think this is amount, oops, there we go, amount of money, times, so I'm going to use the dot for times, R, which is the interest rate, okay, equals I, the amount of interest. The amount of interest earned. Okay? All right. So we have account number 1 and account number 2. Now they just say, so now we're going to look at the problem. We're going to try and fill in all these blocks, or as many of these blocks as we can. They say, well, one account is 8%, one is 3%, right? But whenever we plug in percentages, this is important, whenever we plug in percentages, we convert to decimals. Okay, so be careful. 8% is 0.08, and 3% is 0.03. Now, honestly, you could switch the 0.03 and the 0.08. It won't matter, right? Because we're just generalizing these equations. So we know the interest rate. Do we know how much money is in each individual account? We know the total amount of money, right? Total amount they want to invest is 200,000, right? Okay. But we don't know specifically how much is going into account number 1 and account number 2. So when we don't know, what do we do in math besides walk away? Just kidding. What we do is we use variables, right? Unknown letters. Well, we know the letters, but you know what I mean. The unknown amounts are represented by the variables. Okay, so we follow this equation. We have amount times the interest rate equals the amount of interest. So we multiply across. Okay, so in other words, we're going to get 0.08x. And this one will be 0.03y. Okay, so notice what we did here. Using this table, if we go this direction, we're multiplying. Follow the equation, right? The other rule of this box method here, or chart method, whatever you want to call it, is when we go down, we're going to add. Okay, and that's going to help us get the two equations. Now, notice what they said here. The annual income needs to be $13,600 from the interest is what they're saying. So this is the amount of interest, right? So if we add straight down, we need to get 13,600. Okay? So look at that. We just created two equations. Add straight down. X plus Y equals 200,000. Right? See that right there? We added down. X plus Y equals 200,000. And we're going to do the same thing to create a second equation right there. So we've got 0.08x plus 0.03y equals 13,600. Okay, so we have two unknown variables. We need two equations. That's the rule. However many unknown variables you have, you need that many equations to solve. Now, we can use the substitution method. That's going to be a little bit easier here because we could easily take this top equation and solve for y or x, doesn't matter. I choose to solve for y. So that means subtract x from both sides. That means y equals 200,000 minus x. Okay, all we did was take that top equation and solve for y. Now we'll take this, plug into the second equation there, and see what we get. Okay, so we're going to plug in. So we get, so I'm going to write it down here. So 0.08x plus 0.03, but instead of a y, I'm using 200,000 minus x, and that's equal to 13,600. Sorry, I should have left you more room. I did not. What we're going to do is distribute this 0.03, right? Because it's outside the parentheses. We have to distribute into the parentheses. All right, so we get 0.08x plus, so 0.03 times 200,000, use a calculator if you need, that is $6,000, or 6,000, yeah, dollars in this case. And then minus 0.03x, right, equals 13,600. Now we keep playing the algebra game, so here I'm going to move up here, because again, I didn't give enough room. All right, so first step, combine like terms. So 0.08x minus 0.03x, be careful with those decimals, right? That's going to give you 0.05x, 0.05x plus 6,000 equals 13,600. We're now going to subtract 6,000 from both sides. Remember, when you're doing algebra, the basic rule of algebra, whatever you do to one side of the equal sign, you have to do the exact same on the other side. So subtract 6,000. If you subtract 6,000, that'll give you 7,600. And then we divide by 0.05. So use a calculator, and you will get 152,000. Of course, in this case, dollars, right? All right, now once you finish your math, right, your algebra, go back and read what the question wanted, right? What the question wants right here, how much should they put in each investment? Well, we just found how much to put into, X was account 1, right? So into account 1, 152,000. Okay, we solved that, but now we've got to finish and answer the question for y. In other words, we have to find y. So y, we actually already know. We had this equation. Oops. This equation here, 200,000 minus x. So 200,000 minus x, we know, so I'm running out of room, but 200,000 minus 152,000, which is 48,000, of course, dollars, right? Remember, in word problems, make sure you use the units from the question in your final answer. So there we go. In the first account, we'll put 152,000. In the second account, 48,000. All right, and there you go. And the way I present them here, you're welcome to do this, on a test. Of course, you're not going to have a written test this semester. It'll be on the MyOpen Math, the homework program. But if you were doing these on paper, you should show all your work. All right. Okay. So here's another example, medication. This is a typical test or quiz type question as well. All right, so a nurse has two solutions that contain different concentrations of a certain medication. One is a 12% concentration, the other is an 8% concentration. How many cubic centimeters, or cc's, so you probably hear that in like medical shows and stuff, of each should she mix together to obtain 20 cc's of a 9% solution? Okay, so we got to read into this question here. So we're going to use an equation similar to the one we did up above, but this one's going to be amount times concentration equals total. So this one's easy, ACT, total. Okay, so let's read the question here. So we have solution number 1 and solution number 2, right? So 1 is a 12% concentration, so be careful. 12% as a decimal is 0.12, right? 12% concentration. The other one's 8%, so 0.08. That's important, 0.08. All right. For solution 1 and solution 1 and 2, do we know how much? We don't know how much of each individual. What we do know is at the end, so the total, when we add these up, we want 20 cc's, right? So again, we do what we just did up above. We don't know this one. We don't know this one. but we can add those together. Remember, add down, multiply across the chart here, and we'll get 20. Okay, so again, we're going to use that rule to multiply across, right? A times C equals T. So we'll do 0.12x, 0.08y. And so notice what we did. We did amount times concentration, amount times concentration. So we have to be consistent. So for the total at the bottom here, it's going to be amount, 20, times the new concentration, read the problem, of 0.09. Okay, you see that? Because they want to mix them together, get a 0.09 solution. Okay, so again, we're going to add down, make two equations, go through the process, right? So we'll have x plus y equals 20. Second one, 0.12x plus 0.08y equals, and now 0.09 times 20, okay, is 1.8. Okay, so make yourself a note, that is that number right there. Okay, all right. Okay, just like we did before, so we could use substitution or elimination in this one. I personally think substitution's easier because we could get y by itself again very easily by subtracting x from both sides. Then we take this, we plug into there, things will work out, right? So we get 0.12x plus 0.08. Again, make sure you use parentheses just like I'm doing here. Very important, because then you'll skip your distribution part and you'll get the wrong answer. Okay? So again, we're going to distribute this 0.08 into there and there. All right, so 0.12x plus, so 0.08 times 20 is 1.6 minus 0.08x equals 1.8. And again, the good news here, we have now one variable, only x's right here, right? Okay. So combine like terms. We have x's there, 0.12x minus 0.08x is 0.04x. So plus 1.6 equals 1.8. We want to get x by itself, so let's subtract 1.6 from both sides. So 0.04x is going to be 0.2. Divide by 0.04 on both sides, and x equals 5. Okay, so again, once you do your math in a word problem, go back and read the question. Make sure you answer the question. You could do all this beautiful math, but if you don't answer the question, you will lose points, unfortunately. All right, so x equals 5. So that means we're going to have 5 cc's of the 12% solution, solution number 1. So that already answers the question because it says right there, how many cc's of each? So x and y we got to find, right? We just found x. Y is nice and easy, though, because we could just plug in right there, can't we? So y equals 20 minus 5, so y equals 15 cc's of the second concentration. And there you go. We got the answer. All right. Okay, practice those. Word problems are important. You'll see those quite a bit. All right, we have some definitions we got to go over here. Dependent and inconsistent systems. So these are some graphical representations of what happens when you solve two systems of equations, the three possibilities, the three outcomes. So you could have a unique solution. Unique means one of a kind. In other words, when you solve this either graphically or algebraically, you're only going to have your two lines crossing in one exact point. Or if you do it algebraically, you're just going to have one x comma y pair. Okay? One x value, one y value, single solution. Right? Unique solution means one solution. You could have it where when you solve these systems of two equations, where you get parallel lines. In other words, no solution, an inconsistent system. Okay? You should know these terms. So no solution means inconsistent system. Intersecting lines means unique solution, one solution. And you could also have a third situation here. This system is called dependent. You could have an infinite number of solutions because when you solve these, you'll notice the two equations are actually equal. They just look slightly different. Okay, and I'm going to go over some examples in a second here of what that means. So that means a dependent system, which means an infinite number of solutions. So basically every single point, the infinite number of points on this line, are all solutions to the pair of equations. Okay, so let's do two examples here. I know I didn't write them in. So example number 1 here. So write these down. We're going to get 2x minus 3y equals 4. And 6x minus 9y equals 12. Okay? So in a problem like this, it'd be a little bit of a pain to do substitution because we would have to get one of those variables by itself. It'd be a little bit of work. So let's use elimination on this one. So again, let's look which variable do we want to eliminate. Actually, either one is kind of easy to eliminate. If we multiply this whole thing, this whole equation, every single thing, by a negative 3, right? Let's see what happens. So if we do that, we're multiplying everything, every term, by negative 3. We'll get negative 6x. We'll get positive 9y equals negative 12, right? Now we're going to copy this second equation over, and we'll notice something here in a second. 6x minus 9y equals positive 12. Notice what happens when we add straight down. Negative 6x plus 6x, gone, right? They're eliminated, so that's a 0. But look what else happens. Positive 9y, negative 9y, that's also a 0. And also, negative 12 plus 12 is 0. So we get 0 equals 0. Now that's okay, right? This is a true statement. Isn't 0 equal to 0, right? So whatever you get, you could get 10 equals 10 or 50 equals 50. And if you get a number equals itself, that's a true statement. Whenever you have a true statement, you have an infinite number of solutions. In other words, the two equations are actually the same. If you graph them, they're the same line. They just look slightly different because they've been multiplied by something. Okay? So whenever you have a true statement, 0 equals 0 or 5 equals 5 or whatever, then you have an infinite number of solutions, and that's called a dependent system. Okay? So that's important to remember. We're going to do another example here, example number 2. So we're going to get 2x minus 3y equals 4, and 6x minus 9y equals 36. I know they're similar to the problem we just did, but slightly different, right? So let's do that elimination again, right? We're going to see, well, it's going to work out the same, right? We're going to multiply everything by negative 3. And let's see, so we'll get negative 6x plus 9y equals, negative 12. And we get this positive 6x minus 9y equals 36 because we're just copying that second equation down. Now we add straight down, right? So that one we know is a 0. That one we know is also a 0, but negative 12 plus 36 is 24, right? So 0 equals 24, that's a false statement, right? 0 does not equal 24. So whenever you have a false statement, that is this situation up here. In other words, you have two parallel lines, which means they'll never cross, which means you have no solution. That's called an inconsistent system. Okay? All right, so these are important to go over. Make sure you understand them. All right, so here's another example here. All right, so let's see. Members of an investment club have set a goal of earning 15% on the money they invest in stocks. They're considering buying 2 stocks for which the cost per share and the projected growth per share, both in dollars, are summarized in the table. So you got this table of data right here, right? All right, so if they have 180,000 to invest, how many shares of each stock should they buy to meet their goal? All right. So what we're going to do is we're going to create 2 sets of equations and solve. So here's what we're going to do. So they have 180,000 to invest. So in other words, we don't know, how many utility shares they have. So let's call that X. And we don't know how many technology shares. So let's call that Y. That's the number of shares of each. So we're going to use this data. We're going to say $30 per X per utility, right? Per means multiply. Plus $45 for each Y stock, technology stock, is going to equal the portfolio value of $180,000. Okay? All right. We're going to make a second equation using the second line of data under here. So we'll do the same thing, right? It's going to cost $4.50 for each utility stock plus $6.75 for each technology stock. And that's going to equal right here, look up here, 15% of the 180,000. 15% of means multiplies, right? So 0.15 times 180,000. All right, so we have our 2 equations, 2 variables. This one's a little bit of a pain, so I'm going to kind of just hand this one to you. We're going to eliminate x, so we're just going to multiply by the two coefficients. So we're going to multiply this guy by that and this guy by that. In other words, let me show you what I'm doing here. So we're going to multiply the top equation by, we're actually going to do, we're going to do 4. Oh, what happened here? We're going to multiply that by 4.5, the whole thing. And the whole bottom one, we're going to multiply by -30. Okay? And that's going to help us eliminate the x's, right? So if we do all that multiplication, remember, distribute everything, right? So we should get this 135x plus 202.5y equals 810,000 because we're multiplying. That's for the first one. If we multiply everything on the bottom by -30, we'll get -135x minus 202.5y equals -810,000. So you notice everything goes away, right? Everything's opposite of each other if we add straight down, so we get 0 equals 0. So basically they have an infinite solutions. So there's many, many ways they could invest this money properly, okay? So that's that. It's an infinite solution problem. Part B, if they buy 1,800 shares of the utility stock, so utility we said was X, how many shares of Y should they buy to meet their goal? All right. All right, so we can use either of these equations and just plug in. So they're basically giving us X, the X value. Okay, so we got 30x plus 45y equals 180,000. Well, they're telling us x is 1,800. There we go. If you multiply that out, that's 54,000. We'll subtract 54,000 from both sides. So that should be 126,000. And we'll divide both sides by 45. So y equals 2,800 shares of the Y value, the technology stock. Okay. All right, we're now on to section 2.4. Solutions of linear inequalities. So not equations anymore, inequalities. All right, so let's see. A linear inequality, or first degree inequality, in the variable x is an inequality that can be written in the form ax plus b, which is greater than 0, where a is non-zero. Right? If a is 0, then you don't have a slope. That's a horizontal line. The inequality symbols can be the greater than or equal to, less than, or equal to. All right, so the steps for solving linear inequality algebraically is actually just the same as if you were solving with an equal sign. Okay, there's just one slight difference, and that's where we have to be careful if we ever multiply or divide both sides of the inequality by a -1. Okay, if you multiply or divide by a -1, you flip the inequality. Okay? All right, that's important. All right, so here's an example. So solve the inequality right here. So again, we're going to treat this as if it's an equal sign unless we multiply or divide by a -1. Okay? So what we want to do is get all the numbers to one side of the inequality and all the variables to the other side. So it'd probably be easier to subtract an x from both sides. All right? So we'll get 4x minus 1/5 less than or equal to -2. Again, we want to get x by itself in the end, so let's add 1/5 to both sides. So we get 4x less than or equal to -2 plus 1/5. So we want to add -2 and positive 1/5. So there's a couple ways you could do that. One way is to get a common denominator. Technically, the -2 can be made a fraction, right? By simply putting a 1 underneath it. So what we can do is we want a common denominator. So when we have a 1 and a 5, the common denominator is going to be 5, right? So to turn this -2 into a fraction with denominator 5, we have to multiply by 5 over 5, right? Because 5 over 5 equals 1. We're allowed to multiply by 1 anytime we want because that equals 1. Okay, so we'll get, let's see, 4x less than or equal to. So we'll have, and remember when we multiply fractions, you multiply across the top and across the bottom. That's important. So we get -10 over 5 plus 1 over 5. So this will be 4x is less than or equal to -9 over 5. Now we're going to divide both sides by 4, but we could look at this another way, right? Dividing by 4 is the same as multiplying by 1/4 on both sides again. Okay, and we multiplied by a positive, so we're not flipping the inequality. So 1/4 of 4 is just 1, right? So x less than. And again, multiply across the top and across the bottom. On the right side here, you should get -9 over 20. And there you go. There's your answer. Okay? All right, and you could always check by plugging this in for both x's here, doing your calculations, and making sure you get a true inequality. So either it will be less than on the left or equal on both sides. Okay? All right, so some applications of inequalities. For an electronic reading device, the weekly revenue and weekly cost in dollars are given by these two equations. So R of x is your revenue. Again, that's how much money a business takes in. And C of x is the cost, the amount of money a business puts out. Where x is the number of units produced and sold. So for what levels of production will a profit result? So again, I think we talked about this before, but a profit is when you take in more than you put out, right? So in this case, we want the revenue to be bigger than the cost. Okay? We just plug in, so revenue is 275x greater than 150x plus 12,000. That's the cost. And again, we just use algebra to solve. So subtract 150 from both sides, and we should get 125x is greater than 12,000. Divide both sides by 125, right? Because we're dividing by a positive number, so we're okay. We don't need to flip the inequality. So x is going to be greater than 96, in this case, units, right? There we go. Okay. Example body temperature. When a dog has a temperature over 101 degrees Fahrenheit, it is said to have a fever. What Celsius temperature reading would indicate a fever for a dog? Okay. All right, so again, when the dog's temperature, so here we could say just the temperature of the dog is greater than, 101 degrees Fahrenheit. Okay, so that temperature has to be greater than, so we have this equation here for Fahrenheit. Oh wait, let me rewrite. Oh no, that's okay. That's what I got to rewrite. There we go. So the temperature is 9/5 C plus 32, has to be bigger than 101. 101, there we go. Subtract 32. It's getting sloppy. There we go. And if we subtract 32, we should get 69. Now, we want to get C by itself. So we've got to multiply by the reciprocal of this. Right? So remember what reciprocal means? Reciprocal means flip a fraction. Okay? So we're going to multiply by the reciprocal, the flip of this fraction, in other words, by 5/9 on both sides. Okay? So when we do that, look, we have a 9 over 9, a 5 over 5, so C stays. Multiply 69 times 5, we should get 345 over 9, right? But that's not how you would answer someone's question, right? You wouldn't say 345 over 9 degrees Fahrenheit or degrees Celsius. That doesn't make sense in normal speech. So we'll plug that into a calculator. So we're going to say it's somewhere around or somewhere greater than 38.3 degrees Celsius. Okay. All right. Moving on. So steps for solving a linear inequality with the intersection method. So this is graphically. Set the left side of your inequality equal to y1. So in other words, you're going to get one equation there. And the right side equal to y2. It's another equation. And graph those two equations using your calculator. Like I said, I'm not going to test you on any of the ones that you need to use a calculator for. But you can check them out if you want. So what you're going to do is basically you're going to look at where those two graphs overlap and where their solutions overlap. Okay, so again, not to worry on those. This is the x-intercept method. Rewrite the inequality with all non-zero terms on one side of the inequality and combine like terms. So basically, you're just going to graph all these little lines and see where the window is. Okay. Again, don't worry about that kind of stuff here. Let's do this one here. So when the temperature is 100 degrees Fahrenheit, the apparent temperature, A, or heat index, depends on the humidity. according to that equation right there. So for what humidity levels is the apparent temperature at least 115 degrees? All right, so we got to think something to talk about here. This phrase "at least." Now, people get confused all the time because we see the word "least," but the reality is this is a greater than statement. Because if I say I'm going to give you at least $1, that means $1 or more, right? So that's a greater than or equal to statement. Okay. The other one. So here, let's write this down. At least is a greater than or equal to. If you see a problem that says at most, so if I say I'm going to give you at most $5, that means I could give you $5 or less, right? Okay, so those are important to know right there. Okay, so at least, so let's see what they want. The apparent temperature at least 115 degrees. So A is going to be greater than or equal to 115. All right, and we know A is this equation right here, so we plug in 90.2 plus 41.3H greater than or equal to 115. So again, we're going to go through the process. We're going to get all the numbers to one side, get the variables to one side, and get the variable by itself. All right, so we'll subtract 90.2 from both sides, which is 24.8. Divide both sides by 41.3. Since we're dividing by a positive, we do not switch the inequality around. So the humidity has to be greater than or equal to 0.6. Okay, and on this one, it doesn't say that there's a unit for humidity, so we can just leave it as 0.6. Okay. All right, and then we have something called double inequalities. So a double inequality represents, go figure, two inequalities connected by the word and or. Double inequalities can be solved algebraically or graphically. We're going to concentrate on algebraically here. Any operation performed on a double inequality must be performed on all three parts. So what they're saying is, and I'm going to show you in a second with these examples, but what they're saying is, when we have an equal sign or even an inequality, we follow the basic rule of algebra. Whatever you do to one side of the equal sign or the inequality, you do the same thing to the other side, right? It's the same thing here, but now we're going to have like three sides, I guess you would call it, three parts to the inequality. So let me show you what we're talking about. So here's an example. A student has taken 4 tests and has earned those 4 grades. If all 5 tests count the same, what grade must the student earn on the final test so that her course average is a B? In other words, between 80 and 90%, right? Well, 90% would be an A. So this is how we're going to write this up. So we want this average, right? So first let's find the average. Our average is going to be all 5 tests added up. So 87, plus 85, plus 97, plus another 85, plus whatever that 5th test comes out to be. We don't know. It's an unknown, so we'll use a variable. Since we're averaging them, we're going to add them up and divide by 5, right? There's 5 tests. Divide by 5 to get an average. Okay, so if we put this together, if we add up all those numbers, we get 354 plus x over 5. So this is the average. So what grade on that 5th test will get her in a B? So in other words, we want the average to be greater than, wrong way here. So we want the average to be greater than or equal to 80, right? Bigger than 80, you get a B. Now, it's weird how I'm saying that, right? Average greater than or equal to 80? Well, if you read it from the left, normally when we read an inequality, we're going to read from the variable to the number. So if we're reading it in that direction, this says average greater than or equal to 80, okay? We also want that average to be less than 90, right? Because they're trying to figure out what grade on that fifth test will give them a B only, not an A. Okay? All right, well, we just said A equals that over there. So we got 80 less than or equal to 354 plus x over 5 less than 90. So now this is what I was talking about, right? Whatever we do to isolate x, we do to all three parts. So part 1, part 2, part 3. The left, the middle, and the right. Okay? So to start working on this, what we need to do is multiply the middle by 5 to get rid of that denominator, right? Which means we multiply that by 5 and that by 5. Okay, we're always going to do the same to all three parts. Okay, so we get 400 less than or equal to, the 5's reduce away, and this is 450. Okay, now we're going to subtract 354 from all three parts, right? So this will give us 46 less than or equal to, now x is by itself in the middle, less than 96. So if this student gets anywhere between 46% and 96%, then they will get a B in the class. Okay? All right. Here's another one. Very similar. The mean just means expected time served, time Y, served in prison for a serious crime can be approximated by a function of the mean sentence length X with that equation right there, where X and Y are measured in months. According to this model, how many months should a judge sentence a convicted criminal so that the criminal will serve between 32 and 85 months? Okay? All right. So the time served is this Y value, okay? So we want to find the X values, just very similar to the one we just did. Whoa, there we go. That'll give us these proper values. All right, so here we go. So 32 months less than the equation, well, let's just call it Y for now, less than 85. So in other words, the time served between 32 and 85 months. So we fill in Y is this equation, 0.55x minus 2.886 less than 85, right? So in the middle, we want to get x by itself. So first thing we'll do is add 2.886 to all three parts. Okay. Let's see. So that's going to be, let's see, I didn't calculate these, so let me calculate these real quick. Well, this first one's easy. 34.886 less than 0.55x less than, oh, they're all easy, so 0.886. All right, and then we're going to divide everything by 0.55 so that we just have x in the middle. Okay. Let me clean that up. There we go. So if we do that one, so let's see, 34.886 divided by 0.55, 63.4. You don't have to be too exact on these. There's more decimals, but 63.4 months. And then we'll do the other one, 87.886 divided by 0.55. And that's 159.8. Right, months for each. So if the judge wants the person to actually serve between 32 and 85 months, they have to give them a sentence of 63.4 to 159.8 months. Okay. All right, and that's it. It's the end of this lecture. Thank you very much.